This is a collaboration that we did between University of British Columbia and the University of Michigan. An outstanding question in bird flight for a long time has been, are birds fundamentally stable or unstable?
There's a lot of different fundamental aspects of stability versus instability, and the one that we really focused on is longitudinal, which means like as the bird is cruising forward and it encounters a gust that might push it, one way, how easily can it kind of passively reset back to being in that cruising flight mode?
Compared to like a lot of engineered aircraft, birds have the ability to change their wing shape, and they do this by altering the angle of their elbow and their wrist joint, and that can cause pretty large changes in the area of the wing. As the wing shape is changed, the masses of all the different components in the wing will also move towards or away from the body. And as those masses move during wing morphing, the stability of the bird as a whole can be altered. We would basically track the motion of the elbow and wrist as well as the whole wing shape to get that kind of range of motion, as well as using dissection to find out the masses of all the different components of the wing and of the bird.
Most birds are able to actually adapt a configuration that's either passively stable, which allows them to kind of reject gusts, but they can then adapt other configurations of their wing that conversely make them very unstable and hence very maneuverable. In addition to that, we did an evolutionary analysis led by Vikram Baliga that basically showed quite convincingly that there was a strong evolutionary force to allow them the ability to transition between stability and maneuverability.
When it comes to zoology, we gain an appreciation for how birds work and how they fly from point A to point B. All of the basics of their ecology can be better understood if we have these mathematical models that help us understand how they fly.
This points to some design principles that we should be able to now implement for designing, say, drones, and maybe even in the future, larger aircraft such as those that might carry humans.
We don't necessarily know exactly how to design every UAV out there, but if you at least want a starting point for a certain size or a certain shape, you can be inspired by biology.